Hey, how we doing, boss? How we doing today, my friend? Let me bring this up here. Give me just a second. Let me get to the big screen here so you can see me. How we doing today? How you doing, boss? I hope things are going well. And you're already brilliant. You don't need like math stuff, my friend. You're already brilliant. To be honest with you. you're already good in my books, my man. I ain't gonna lie. I forgot how to do log multiplication. That's okay. You want me to show you an example? I'll be happy to show you an example. Go with the standard, cross out method. Totally up to you. If it helps you, with your, if you have like family members who are in school and stuff like that, if it helps you help them, yeah, yeah. But the box way of doing it is okay. Like I know about the box method. Like here, I'll show you here. So go to the big board here. All right. Hey Jess, hello. Good morning / afternoon. How we doing today? Let's say here, boss, we had to say 234 times. We'll just make up some numbers. 516. Okay. So like the log multiplication method here would be like, okay, you take each individual number that you see here in 516. So start from the rightmost number here of 6. And multiply it by each one of these respective numbers going from right to left. So we start off with, say, 6 times 4. All right. So 6 times 4 here is going to be 24. And then we carry the 2. So then we have a 6 times 3, which is 18, plus 2, which is 20. And then we have carry the 2 once again. 6 times 2 is 12, plus 2, which is 14. Now, what I like to do is in the old school way, well, the way I kind of helps me is I want to cross out the column right underneath the 4, because I'm gonna essentially what you do is we'll move one column here to the left, and now you want to repeat the same process here, but this time instead of using the 6, we're gonna use the next number over here, which is 1. So I'll put this in red here. So we got 1 times 4, which is 4, nothing to carry over. 1 times 3, which is 3, easy peasy. 1 times 2, which is 2. And now we want to go ahead and put 2 crossouts underneath here. We're going to move one column over here to the left. One more go around. And now we're just going to go with the 5 here. Josie, hello. Good morning / afternoon. I hope you're doing well. Then we have 5 here. We got 5 times 4, which is 20. So we'll put a 0 here for the end of 20 here. And we have 5 times 3. We'll carry the 2 here from the 20. 5 times 3 is 15, plus 2 is 17. Okay, and then we carry the 1 there from that. 5 times 2 is 10, plus 1 is 11. And so now all we're going to do here simply, boss, is to go ahead and add up each column here. Just add it up like you would regular stuff. The X's here represent 0, so they don't do anything. And just add straight down, and just like carry stuff over. So you get 4, here we get another 4, 4 plus 3 is 7, 1 plus 2 plus 7 is 10, gonna carry the 1 over here, get 2, and 1. So our final answer here will be 120,744, and that's how we can go ahead and do a long multiplication for you. Bernice, hello. Good morning / afternoon. I hope you're doing well today. And just start off with a question boss had for me for doing old school long multiplication. So oh, okay. I hope this refreshes you just a little bit though. Yeah, 19 times 17 would be even easier. You always start with the rightmost number here, right? Start with the 7. You get 63, carry the 6. get 13, cross out. Then you start with the 1, get 1, 9, 3, 12, that's 3, 323. There you go. Got yourself 19 times 17. So that's how you do the old school long multiplication. Oh my goodness. I totally understand. No, I understand. It's been 36 years, my dude. 100% I understand that. That's why I'm like covering it very carefully, you know? Give yourself a friendly reminder. No problem, my man. Anytime. Nothing. It has been like 20 years since I've done certain subjects in math, to be fair. Hey man, if it helps out if it helps out any of your nieces, nephews, grandkids, whatever, any family members, be more than happy to help you out. So you can be an asset. Khadija, good morning slash afternoon. Good morning slash afternoon. Hopefully you're doing well. Nicholas, hello. Hello, right back to you. Good morning slash afternoon to you. Welcome back. Welcome back. Welcome back. Good to see you everywhere. Grandkids are better than me at math. Oh, that's cool. You know, but sometimes it's good for grandpa to step in, you know, kind of help him out if you have just a little bit more. Joe says, ask a question. Go ahead. Ask away, Josie. Please, feel free. More than welcome to ask a question anytime. Go ahead. On my math lab, there were questions in regards to graphs that we did. What does it mean to find a relation of graph A and the B? Had to run out and get a Subway because of the Craven one. Oh, good. So assigning a relation here of graphs A to B here. So, I'd have to take a look at the question here. Do you remember what question that would be? I can put it in better context, and then I can give you a definitive answer. You take a look at the question there, so I can see exactly what it's asking for here. Either it's asking for points, you know, or it's asking for a function, or it's asking for something. So, it's asking for something, obviously, but I just want to be sure that I put it in the right context compared to the question that you have there, Josie. Let's take a look at that. Let's not take a look at that screen. Well, okay. Oh, right. Okay. I forgot about that. 2.1, question 15, the second part. Okay. Subway with some venom equals the ultimate combo. What about you know, while I look this question, what about Jimmy John's? Jimmy John's and Kano Bueno? Jimmy John's no? Yeah, I don't know. I'm just kind of throwing it out there. I think Jimmy John's better than Subway. At least that's what I think. You know, I know that we're gonna we're gonna have some people disagree with me, but that's the point. I'm just a Subway person. Oh, okay, that's fair. Oh yeah, oops, forgot to turn off my dark reader. All right, give me a second. JJ isn't. That's fair. That's fair. True. True. Seems like I favors Mr. Submarine. Sam, I haven't had a while. It's sad. It's sad. Why is it sad, man? Alright, let's take a look here. Graph the given functions f and g in the same rectangular coordinate system. Describe how graph g is related to the graph of f. Okay. Okay, I see what they want. Alright, let's go ahead and, gotta use the graphing tool. Absolute value, we're actually going to talk about this today if we get to the last section. We haven't really talked about this in greater detail, but, let's see here. We got, this and one. Alright. And then we have absolute value of x plus 8. So what is that going to be? Here. There we go. Now I know this is correct. All right. All right. All right. So in this case here is how is the graph G related to the graph of F? Well, the thing is here, Josie, is that if you see the first graph here is this big V here for the absolute value of X. Then just compare it to what happened when you drew the absolute value of X plus 8 like it is in this particular instance. In this case here, the graph actually shifted up by 8 units. So the answer here for this question would be D. The graph of G is the graph of F shifted 8 units vertically up. Okay, so we went from here, 0, 0, all the way up 8 units. And then we can go ahead and check that part. And then that's what we got. Now, we haven't really expanded upon this too much. We are, like I said, we are going to talk about this in this chapter here in section 2.5, so that is something that is definitely on the agenda. So some questions here will be answered kind of in later sections. For whatever reason, they kind of put it out of order. But I want to cover kind of all of it at the same time. So to be fair, I will acknowledge more of this question here if we get to that point here today. So that's the and any question. All right. All right. Ladies and gentlemen, let's do some introductions. All right, and we're going to go ahead and get started here since it's a little bit past noon. Let's go ahead and do this here. All right, let's do this. Let's do some intros. Yes. I can't clap today. Clapping is hard. It's a skill that I don't know how. All right, there you go. Okay, let's get started today. Welcome back to Thursday, end of the week time today. So today, ladies and gentlemen, we are doing, we are going to be finishing off here section 2.2. We're going to be essentially kind of skipping section 2.3. We're going to be doing parts of section 2.3, but really kind of skipping it a little bit because a lot of the questions in 2.3 and 2.4 kind of meld together. And then hopefully we'll get into a little bit of section 2.5. We'll see exactly how far we get. We only have one thing to do here in section 2.2, so we'll quickly finish that up and that here. Music is fire. Yes, this Toho T Stebbins. Which one is this again? That is which one is this? Oh yeah, that's I Seek. Yes, that's what we're gonna go with. We'll go. I'll just put this here. There you go. Perfect. Perfect. Yes. Mr. McKay, good afternoon. Good afternoon to you. All right, let me pause this. All right, I gotta pause that. All right. Hey, try hard French toast. Hey, long time no see, my good sir. Long time no see. Good to see you, my friend. All right. So let's go ahead and talk about here question number 5. Let's go to the big board here. Question number 5 is a type of question here that you will see if you go a little bit further here, especially in calculus. This is where this particular question is applicable. I'm doing absolutely fantastic. Try hard French toast. Absolutely fantastic. Been a good day already. Okay. So number 5 says, how do we evaluate the difference quotient of a function? Now this is going to kind of harken back to what we did here yesterday when we were evaluating functions and whatnot. And we're going to be applying the same thing here. So if you're talking about the basics of derivatives and whatnot in calculus, this is like one of the first basics that you learn here is learning how to do the difference quotient. And again, it just uses the basis of stuff that we talked about here yesterday. So let's go ahead and do an example here about how you take a look at this. And it really honestly isn't too hard. Again, a lot of the same things that we discussed here yesterday, we're going to go ahead and apply. So let's take a random function here for number 5 and let's apply it here. So let's say we have f of x. I helped you a lot with maths. You doing well because of me? Oh man, thank you. I thank you. You know what? Try hard French toast. It's because you did it. You put forth the time and the effort to get better at a subject that you had struggled with. So I'm glad that I was able to be a catalyst, a way to get better. But you did all the hard work, so you should pat yourself on the back um for getting better at maths. So, it's definitely a good on you more than it's a good on me. I really appreciate the compliment. It's really super kind. But you should also recognize the effort that you put in, my man. 100%. Now let's put 2. Yeah, you know what? 2x squared. Why not? Why not for the lulls, everybody, for the lulls. All right. Hey, effort should be recognized as much as the compliment. So, all right. So here we have f of x is equal to 2x squared minus 5x plus 3. All right. Now, if we're using the difference quotient here, let's go ahead and again, let's remember what we did yesterday. Let's start off with the toughest part here, which is, of course, f of x plus h. Okay. Hopefully give you a friendly reminder here. How would we write out f of x plus h? How would that work out here? How does f of x plus h look like before we solve for all that stuff? What would happen if we plug that in? What would that look like, guys? You guys remember from yesterday. Take care. Take care, Tribe French Toast. I hope you have a wonderful day. What does that look like? FX and FH? Oh no. I think that's what we want to do here, just because they're 2 letters. Remember, think back to what we did yesterday. Remember, H would be like a number, it'd be the same thing, right? We're not distributing here. We're using the notation that we learned here yesterday. Oh, okay. All right, so Carla and Josie, yeah, that's correct. Okay, you put x plus h here in there, so we have 2 times x plus h quantity squared. I'll get to hydrating here in just a second. Minus 5 times x plus h plus 3. Good, that's right. So today I have some leftover pop. Um, I have some. I had some leftover pop from last night. I had like a late night Taco Bell run. I was like, okay, I got some Baja Blast. I got. So there you go. Ironically, the first time I've ever tried Baja Blast. It's pretty okay. All right. Okay, so I know a lot of people profess to loving Baja Blast. So all right. Let's take a good look here at x plus h squared. Okay. All right. So again, um, if I'm drinking pop, does that mean a pop quiz? Well, let me be honest with you, boss. Uh, one of my biggest pet peeves was always taking pop quizzes or surprise tests. So my teaching philosophy 101, boss, is to never give surprise quizzes or tests. So I always be sure that I make sure I never ever do that. If you sit in the other chair, if you sit on the other side, you're like, I hate pop quizzes and tests, and it's like, well, yeah, I don't want to. If you're standing in the position of so-called power, yeah, it's like, man, like creating more work for yourself than you need to. Okay, today is National Iced Tea Day. Oh, that's pretty interesting. If it's National Iced Tea Day, does that mean that, if you're of drinking age, you get that twisted tea stuff from like Jewel or something like that? Pour yourself a little bit of hard lemonade, call it iced tea, and call it a day. Yeah, you could do that. I don't know. Like, No, iced tea sounds like it's better with 5% alcohol by volume. All right. Anyway, I digress. Okay. Okay, so what I want to look at here is I want to look at x plus h quantity squared. Okay, so remember here, one of the things we talked about here yesterday is not to forget that middle term. Okay, so this is going to be x plus h times x plus h. So hopefully this will give you a good reminder about what we did here. Yeah, we got to foil that bad boy. Horrible Monkey, good to see you again. And by the way, thank you again for the 5 gifted subs from yesterday, man. That was super kind of you. I saw Parting win against Nina. That was pretty epic. Pretty epic. All right. So we're going to FOIL this here. We got x squared. X times x is x squared plus xh. So I have a question. How did you know to write the equation like that? So it's like x plus h squared if you're talking about that, Joseph, like x plus h squared. If that's what you're referring to, or you're talking about the function. Like, how did I know how to write the function like this from f of x to f of x plus h? Yeah, before. Okay. So here's what I think you should do, Joseph. All right. So this may be helpful for you. All right. So I wrote in f of x plus h. I said, okay, how do I know that it's going to look like that? Remember, all we're doing here, if we're trying to evaluate a function of any variety, whether that be letters or whether that be numbers, okay, all we're doing here is we're playing a substitution game. So if it helps you, just draw it out. And I literally mean draw it out, meaning to say, let's just say I underline x plus h, right? Just say you underline x plus h on a sheet of paper or something like that. And just draw arrows exactly where x plus h would go in your original function. It goes in every place where you see x in f of x. And that is why you see the way it is written just like so. And again, anything we substitute here, Joseph, we're going to go ahead and put parentheses around. So that's why we have 2 times x plus h quantity squared minus 5 times x plus h, and then the plus 3. So if you're not sure how you can kind of mentally build that picture, no worries. You can go ahead, draw a little arrow, know exactly where you need to put it in each little guy, and then you're like, okay, that's what it's going to be. Remember though, you do need to use the note that you put parentheses around anything you substitute, so you're going to have to go ahead and put that together. All right? But once you know that little rule, it really is pretty easy after that. Okay, cool. All right. So here we have, we're going to FOIL here with h here next. So we got plus h times x, and then h times h is h squared. So what we have here is that we have x squared. Now, one important thing about this is that xh and hx are the same exact thing. There's no difference between these two guys. Okay, it's like saying 3 times 2 and 2 times 3. They both equal 6. They're both the same. All right, same thing applies here with letters. When it comes to multiplication, you can flip them around. Works. Commutative property is helpful. So this is going to be 2xh here at the end of the day is what that's going to be. Okay, so that's what x plus h quantity squared is going to be. So let's take stock in what we have here. So first, we have 2x plus h squared. So I'm just going to rewrite that as what we just found here. And then we have minus 5 times x plus h, and then plus 3. All right. Now after that is we're going to go ahead and what you call it? We're going to go ahead and distribute here. So let's distribute and see what we have. So we have 2x squared plus 4xh plus 2h squared minus 5x, again because of negative 5 here, minus 5h plus 3. Okay, so notice here there are no like terms here. Again, this is just taking care of, by the way, just the f of x plus h portion, okay? We haven't done everything else here, a part of the difference quotient. We just took care of the first part here. But before we move forward here, are there any questions about how I found f of x plus h? No. Okay. All right. Let's go ahead and move forward then. Okay. So next, what we're going to do here specifically is let's do f of x plus h minus f of x. So we're going to take all of this stuff here is f of x plus h. All right. So let's write this down one more time because there's certain things that we want to do. And what we want to do next here is we want to subtract by f of x. Now, because we are subtracting by f of x here, remember that f of x here needs to go in parentheses. Remember, anything we plug in, we got to substitute with parentheses. And this becomes extremely important because this is going to significantly cut down the entirety of this problem as a result. So you're probably saying, wow, there's a lot of gobbledygook here. There's a lot of letters and numbers and all that stuff. Well, let me tell you, having that parentheses there makes this significantly easier. Now the question is, well, why does that happen? Well, in this case here, we're subtracting by that entire that entire equation. So essentially, we're going to distribute the negative to each one of these terms in that f of x. So what we have here is we have 2x squared plus 4xh plus 2h squared minus 5x minus 5h plus 3. But now we have minus 2x squared plus 5x minus 3. So that's what we have here so far. Now, why is this convenient? Again, take a look at what we have here. Look, the 2x squareds, they'll cancel out because we have 2x squared and minus 2x squared. The minus 5x plus 5x, so those cancel out. Super convenient. And we have plus 3 and minus 3, and those get to cancel out. So we're effectively just wiping out a whole bunch of terms. So all we're left with here, after everything is said and done so far, we're almost there though, is 4xh 4xh plus 2h squared minus 5h. And remember, we're dividing everything here by h, right? That's the last part that we need to go ahead and acknowledge here. Now, all you have to do here at this stage is go ahead and factor out an h here at the very top. Notice we have an h in the first term, second term, and a third term here. So if we factor out at h, we're going to have 4x plus 2h minus 5. And we divide that by h. The h's cancel out, and that just leaves you with your final answer here of 4x plus 2h minus 5. And that's it. So that one last extra step gets you to cancel some more stuff out, and bada bing, bada boom, winner, winner, chicken dinner. Where'd I get the 2x squared minus 5x minus 5x plus 3? That's the original function there. That's the original function that we defined here. So I just kind of made it up. That's right from the beginning there. I know we take it like one step at a time here. So first figure out each piece at a time. First figure out the f of x plus h here. Then we figure out, after subtracting out the f of x, and then we take that top part there, factor out the h, and then divide. When is the first test or quiz? Not yet. I don't think we are there just yet for the first test or quiz. I have like a lot of work to do this weekend, so in regards to that question, I have to look at the syllabus here. I think that's over chapter 2, right? Follow that thing. Yeah. So we're not done with chapter 2 yet, which is where the first test will be. Will it be next week sometime? I'm gonna have, like I said here, kind of the first day here on Monday. Um, I don't want to announce anything in regards to the test just yet, and it's not me trying to hide the information from you. It's just that I have like certain things I want to go ahead and lock down and finalize through my math lab and stuff, because all the tests are going to be on my math lab and stuff. So that's going to be like a given, is that you'll be able to work on it online. Um, but I have a few things that I have to do behind the scenes here to make sure I give you all the information here. Of course, I will let you know about the due dates here, because that's actually still in limbo in regards to when we're having the test. It also depends on the pacing of the course. So it depends on how fast we get through some of the material there. So um, if it's and by the way, if it's a due date, it's always a week after we finish the material typically. So if I say finish up chapter 2 by next Monday, then I'm going to have the test due the following Monday or something like that. So it'll always be a week ahead of advance. Okay, I never give like, oh, you got 3 days to finish, have fun, and then I laugh maniacally. I mean, I could do it, but yeah, I'm not going to. So definitely not. I would like to give a week's worth of warning, but this class will be a little different because we're in the summer's time, so I might have a few more. But I'll let you know here once I make everything up here this weekend. Why would you distribute a negative 2 and not a positive? The reason why we distribute the negative here, Fritz, is because we are subtracting by f of x here. So based on the formula here for the difference quotient, we are actually always distributing the minus sign there. Do I teach business calc? Yes, actually, I'm teaching business calc at 6 o'clock tonight. That's ironic you asked that. so, so yeah, yeah, it's because of that minus f of x in the formula. That's why we're always going to distribute that minus sign. That'll be a given. But I wanted to show off exactly why that's happening here. You're gonna take it next semester? I was wondering. Oh, okay. I don't think I'm doing it in the fall. Again, it's rare that I get a chance to do 126. Um, but I'm doing stats. I think I'm doing stats in the fall, but I don't get like total amount of choices all the time, so it's just whatever's kind of available at the end of the day. They give me a schedule like pick stuff, and I'm like, oh, a lot of people picked before me. Like that's a sad face. I got to work with what I got. No, no, no. I got to do it in the fall. Drop the other. Oh no, that's a little tough. We set that schedule in stone like a couple months ago. I'd be happy to though. Okay, okay. Let me at least say this in relation to that comment, Blink. To be fair, if you guys need help in future math classes, if I can help in any way, you can still feel free to contact me if you need help. So even if I'm not your professor, teacher, what call me. All right. You can always contact me and say, hey, you know what, Professor Chibs, I need some help with this, that, and the other thing. So, you know, even if I'm not there, hold out my hand and be like, yeah, you don't have to be alone when it comes to things like that. Thank you, everybody. It doesn't mean look, yeah, just thank you. Yes, it doesn't mean that yeah, it doesn't mean that that's because the semester's over. It doesn't mean we just cut off relationships. That's not how it works. I mean, like I told you, if I'm here for your success, that just also means after the class is over as well. Your success is important. I want you to be in a better place. You know, if you're having a, and I've gotten students before in the past who come over and help me. They're like, I'm not sure about this topic because it wasn't so clear. Can you help me out? I'm like, yeah, sure, I'll help you out if I can. I'll be more than happy to help you out. Can I contact you for physics? Sadly, no. Physics and me, we're not best buddies. Thank you for the hydrate. Will I help you with programming? I haven't done CS in 20 years, my dude. I can do basic C++, but man, I haven't done programming in 20 years. I'd be more of a burden than I would be of a help. I'd be happy to talk about programming, but man, I haven't coded in so long. I haven't coded in so long. It's been eons. Eons. Well, yeah, it confuses me even more. That's where I'm a detriment. If I confuse people even more than that, that's where I'm like I draw the line for myself. I'm like, oh, I don't want to be that guy who makes it worse. uh, all right. Any other questions? I guess you guys have been asking questions today. It's good. Any other questions you guys have over difference quotient stuff? Okay, let's go to here we go. All righty. Go to this next part here. Okay. Okay, let's take a good look here at section 2.4. Now, like I said before, section 2.4 is basically like a mismatch of like section 2.3 and section 2.4. So, Snap, are we learning calc today? No, not in this class anyway. Business calc when I teach that later tonight. That's where I'll be teaching most of that stuff as the basics there. We're actually going over limits in that class. Um, but this is just algebra stuff. So you get the little hint with the difference quotient, but then that's as far as you go for a while. Um, Okay, now section 2.4 talks about lines. Okay, we talk about, say, that now section 2.3 talks about the basics of lines and whatnot. We'll talk about that here, about linear functions and the like here also. In 2.4, they also talk about more about slope and just expand on the topic. So that's why I'm just kind of doing it two at once here. 2.4 just going to encompass 2.3 as well. So these questions basically are going to cover both sections. All right, now let's take a look at the first question here on the handout, and let's talk about it. All right, number one, how do we find the slope between 2 points? All right, now first of all, you've probably seen this before if you've done previous algebra classes in the past, but just to give you a little refresher here, the notation for slope here is going to be m, and we have 2 points here, which is going to be x1, y1, and x2 and y2. If we want to find the slope between these 2 points, as you can see here on the screen, the slope here is going to equal rise over run, or being equal to y2 minus y1 over x2 minus x1. All right? So you've probably seen this before about finding slope between 2 points. Maybe you've seen it in the past. If not, if it's been a while, hey, there you go. There it is. Okay, I'm going to come back to this in just a second, all right, because we will do examples of this, but we have a little bit more to kind of do or kind of discuss here. So we're going to answer a few more questions. I'm going to skip a couple questions and then I'll come back to them. And then because some of this stuff is kind of done a little out of order here. So, but let's talk about number two, and I'm going to skip a couple questions. I'll go and then we'll come back to number one. All right. Number two here is what is the slope intercept form? All right, so slope intercept form is really what we're talking about here in these two sections. Again, linear functions or linear equations. Again, y equals mx plus b or f of x is equal to mx plus b, whichever way you want to call it. Y equals mx plus c in the most common way that you hear it most of the time. Again, m being the slope here as we defined from before, and b being the y-intercept. Okay, again, the y-intercept is something we defined here on the first day, which is, again, you plug in x is equal to 0, so you get 0 comma 3 or 0 comma 5 or 0 comma 7 as a y-intercept, wherever that point on the y-axis for that line is be. Now, what are we doing in these couple of sections here? What's really going on? Well, what's really going on here is, and I'm going to go ahead and skip here, squish numbers 3 and 4 here for just a second, is we're going to go ahead and use a couple of tools at our disposal here to find equations of lines, okay, and also find average rate of change. Okay, so if we're finding equations of lines, all right, and we want to say find an equation of line between 2 points, we're going to need one more tool in our arsenal of which to do that, and we'll do an example here together as well. So the tool that we need here in our arsenal is the point slope formula. That is here in question 5, which asks what is the point slope formula? So the point slope formula here is equivalent to y minus y1 and equals m times x minus x1. Now this may seem a little strange, okay, but the reason why I like the point slope formula is it is a little bit more direct than the slope intercept form. We're going to get into something that looks like y equals mx plus b doing some problems here, and that's a fact. Okay, but the way we get to that y equals mx plus b actually is actually slightly a bit faster and a little bit easier, in my opinion, using the point slope formula in comparison to just doing y equals mx plus b a couple of times. You'll see exactly how that works out. I feel it's a lot easier because you can actually physically see where the places come in. Plus, you only need 1 point. Now, technically, you need 1 point here for the y equals mx plus b there, Danny. But you don't have to do this calculations 2 times, which is kind of a pain in the butt. Um, that's another thing. The other thing that I guess I could say here as well is that not only is it more direct, it is again it works a lot easier in a lot of different topics with lines again, and as you say here, needing 1 point as opposed to two is certainly one of those things. So I don't disagree with that. It's just like I'm like just like gotta find the easiest way, path of least resistance, right? We're all lazy people, all right, to a degree. So it's like, well, let's find the path of least resistance. Sounds good to me. All right. So the one thing though that this also does do is basically we need to take this note into account. Is this reduces the amount of confusion using y equals mx plus b compared to the point slope formula. So let's take a look here. What's the biggest advantage? This note here is where the biggest advantage comes into play. It says, note, do not plug in anything for x and y. Okay, so one of the causes of confusion here is you're like thinking, I have to plug in something for x and y. My thing is that I don't want you to plug in anything in for x and y. The only things you should plug in using the point slope formula should be the slope for m and the point, x1 and y1. Okay, so now comes the real question here. Let's say we're given 2 points and we want to find the equation of that line. Let's go ahead and make up a random 2 points. Let's go ahead and take a look and see what happens. All right. So I'm just going to randomly make up 2 points. And again, this can apply in a lot of different circumstances, and applications and whatnot. If you have 2 points on a line, you can figure out what that slope of that line is that goes through both of those points. But I'll make it up here. I don't know what I'm doing about half the time. So let's yeah, let's do it. 1 comma minus 7, sure. And I don't know, minus 4 comma 8, sure. Okay. Now I've just randomly made up 2 things, okay? So, if it comes out to be not the nicest numbers, that's okay. All right? It just depends whatever numbers that we get here at the end of the day. All right? So, all right. So what we're going to do first is let's go ahead and take a look at step 1. Step 1 says find the slope using the formula for the slope between 2 points. All right. So using that slope formula here, we're going to go back to number 1, and we're going to use this rise over run. Okay. Now to reduce the amount of confusion here, now you're probably saying, well, that's going to be y2 minus y1 over x2 minus x1. I said, okay, that's fair. But to reduce the amount of confusion a little bit further, a great thing to do here, a really good idea for all of you to do, is to go ahead and label your points. So make sure you label your points here appropriately so you know exactly where they need to go in the formula. So for example, here you have x1 and y1, and you can label this second point here x2 and y2. Okay. So this the most common mistake I see when trying to find the equation of lines between 2 points is forgetting x1, y1, x2, y2. Because people often confuse, oh, this is, what have I seen on tests? X1 and x2, I've seen that. I've seen this reversed around x2 minus x1 over y2 minus y1. I've seen that before. Hence why I like to use rise over run first. So rise being y, run being x. Okay, now let's plug it into the formula, see what we get. So we have y2 minus y1. So y2 is 8. Again, put parentheses. Remember, always put parentheses because in this formula, because we have minus signs, signs could easily change. So we don't take that for granted. We have minus -7. Here we have x2, which is -4. And then we have minus 1, x1. Okay. All right. Let's see what we got on top here. We have 8 minus -7, so that's 8 plus 7. That's going to be 15. Okay. And then on the bottom here, we have -4 minus 1. That's minus 5. So we have 15 divided by -5. So that came out pretty nice. By randomness, it came out to be -3. Okay, so -3 is our slope. All right. All right, so hopefully that made that a little bit easier. Okay, let's go to step 2. Step 2 says we're going to use the result of step 1, which is finding that slope here being 3, and -3, pardon me. All right, and any one of the 2 points given, let's say given, so give, and plug it into the point slope formula, and then solve for y for that last step. So you can use any one of the 2 points here. You can use 1 comma -7. You can use -4 comma 8. It doesn't matter which point you use. You will end up with the same answer no matter which point you use. Okay, so now the point I like to use here is the one I've already labeled x1 and y1. That's my preference there because it's like, okay, there are already 2 numbers defined as x1 and y1, so I'm just going to go ahead and use it straight away. So let's first write that down. Okay. Uh, ba-da-ba. All right. So plugging it into the point slope formula, we have y minus y1. Now again, we do not want to enter in anything for x and y, so we're going to leave y alone, right? We're just going to have y. Y minus y1, so y minus -7 equals m -3 x minus x1, which is +1. All right. Now we're going to clean this up a little bit so we know what to do here next. So here's where we're going to go ahead and solve for y now that we have this in an appropriate manner. So cleaning this up here, we have y minus -7. We have y plus 7 here as a result. Equals -3 times x minus 1. Distributing the -3, we get -3x, and then -3 times -1, that'll be +3. Finally, we need to solve for y, so all we need to do lastly is to subtract by 7 on both sides. And so here we get y is equal to -3x minus 4. And there we go. That is going to be our final answer for our problem, -3x minus 4. Are there any questions about that particular example? Hopefully that made it a bit easier to see that everybody is on board. So, okay. Yeah. Good bends. I approve of these beans. Very good. All right. Okay. So that is how we can go ahead and find that there. Yeah. You want question 1 and 2? I'm pretty sure. So I'll go up there. I'll also scroll up here. Yep. All right. All right. So we have again the slope between 2 points here, and we have the slope-intercept form here. I think we're okay. So far, so good. All right. Now we have the point-slope formula. All right. Let's go ahead and talk about here the thumbs up. Yes. Yes. Indeed. Thank you, Jess. Bring some Baja Blast. There you go. All right. Okay, now we're going to talk about two more things here in actually a few more things I should say. Let's go ahead and talk about the next part here. We're going to answer questions 3 and 4. I've left a couple of these parts blank on purpose. We'll answer them together. All right, so number 3 says, what is the equation and slope of a vertical line? All right, so first and foremost here, let's talk about a vertical line. Well, all vertical lines have the equation x is equal to a, where a is any number. You probably be saying, well, hold up a second. What exactly does that mean? Well, if I have, say, an equation, I have, say, oops, not y. I have x is equal to 3. Okay, let's just go with that. All right, so what does the graph of x is equal to 3 look like? Well, it's a horizontal line. It's going to look like this, okay, the line in purple here. There you go. That's a vertical line. Now, the question is, though, that I have is like, okay, well, what's the slope of that vertical line? So numbers 3 and 4 are unique slopes that we can find here in particular lines. What is the slope of a vertical line? So meaning to say, let's say we put a ball on the line, right? And we just let it go, right? What would happen? So Khadija says undefined. Okay. What do other people think? You know what I'm gonna do? All right. Slope of a vertical. All right, so let's put this poll up here. Let's see what people think. Usually it goes down to one of two things. So put the poll up top here on top of chat. All right, so the slope of vertical line, is it undefined? Is it 0? Or is it Mario Death? That's we got that's full time indeed. I want to see where everybody kind of is thinking at this time. So all right. It's a pretty even split here, actually, between undefined and 0. I see a couple stragglers, Mario Death. All right, let's take a look here. So 5 people said undefined, 4 people said 0, and 2 people said Mario Death. All right, so that's fine. I mean, the brain is like, let's jump into a pit. um, okay. What's the answer to this here? The slope for all vertical lines are, and let's go ahead and put this in here, are undefined. Undefined is the correct answer here. Okay. So undefined is the correct answer here. All right. So again, now how do you know that here? Well, let's take a look at the graph here. Again, the graph is just a regular vertical line. If you put a ball on that line in particular, that ball is just like on a sheer cliff face. Okay. I don't have time to answer. Please don't. Bernice. I don't know what to tell you. No, I'm just kidding. um, I don't remember this because the math teacher made us watch a video where a dude was climbing a hill with different types of slopes. He falls off. It's crazy. I guess that's one way to remember. I just think of it as a ball. It can fall off a sheer cliff face, and the balls can keep going down forever. But it the ball can literally do anything because gravity is just going to bring the ball down. Not it doesn't have anything to do with the line at all. So it could bounce off the cliff. It could, the ball could, just touch it for a little bit. It doesn't really matter. So the answer is undefined. If you tried using it with like question one with like rise over run, you'll figure out that you'll divide by 0. And in reality, it's like, okay, have undefined. Slope dude. All right. So that is question number 3. All right. How about question number 4? Let's look at that guy. Go over these two guys quickly. Have a pretty good handle on things. What is the equation and slope of a horizontal line? So all horizontal lines are of the form y is equal to a. So let's say y is equal to 2 or 3 or whatever. Doesn't matter. So let's say y is equal to 2. We have a perfectly horizontal line. All right, where a is any number. What is the slope of a horizontal line? What's the slope of a horizontal line here? We put a ball on a horizontal line. What's that slope going to be? Okay, so right, if I put a ball on that horizontal line, right, at the equation y is equal to 2, right, then the slope here is going to be, the slope for all horizontal lines are 0. That is correct. We can't use Yoshi to save us this time. I'm sorry, the horse must be thrown into the pit, and you must use him as a jumping mechanism. All right? And that's just how it has to be. I'm sorry. All right? So the slope for all horizontal lines are 0. 0 slope, correct. So like m is equal to 0 is Blink, thank you for the follow. Thought you did follow me though. But thank you again. um, slope for all horizontal lines is m is equal to 0. Okay, so the slope here is 0. The ball wouldn't move if it was a perfectly level field. So if it's like a perfectly level floor, if you put a ball on a perfectly level floor, the ball shouldn't move whatsoever in either way. Blink says same something nice. Okay. Blink, I think you add a very positive effect to the community. I really like the fact that you've been participating in this first week of class already. And I'm more than happy that it is a clear indication that you are helping yourself. So I'm looking forward here to the next 7 weeks for you making even more positive contributions and progress. Um, that's my saying something nice. There you go. Bursty, hey, how you doing? I'm doing great, my dude. How you doing? Hope things are well for you. Okay, good. We got that down, no problem. Today we're doing some college algebra, firsty. That's what we're doing, some college algebra. Doing some good old college algebra. All right, let's see that out. There we go. Okay, let's take a good look here at question number 6 and 7. All right, so this is another two questions here that we can talk about here. Talking about parallel and perpendicular lines. I'm only 13. Might stay and see what I have to. Yeah, absolutely. First year, you're always welcome in here, my dude. Yeah, this is maths that you would see a little bit later on for sure. So I definitely know that they would teach this in for GCSE and definitely 100%. Okay. So number 6 says, what is the slope if two lines are parallel? All right, so let's talk about that here first and foremost. So if two lines are parallel to each other, then they'll have the same exact slope. All right, so now I labeled this here specifically as new slope is equal to the old slope. Now I did do that here on purpose, okay? So there is a reason why I did this on purpose, all right, as we're going to use this little context here to solve for parallel and perpendicular lines. All right, so we're going to see that in action here as well in these next few examples. Um, Now for number 7 is, what is the slope if two lines are perpendicular? If two lines are perpendicular, then one slope will be the negative reciprocal, i.e. the negative flip, which I find to be a lot easier to understand, of the other. So the new slope here would be equal to -1 over the old slope, or the negative, if it's like a fraction of some kind, you would flip that fraction over and you tack on a negative, and then there you go. You got yourself a win. Okay? Now, the real question is how we find the equation of a line that is either parallel or perpendicular based on the cases that were given. Let's go ahead and take a look, see how it works out. All right. Okay. Alrighty. So in this case here, it's going to be a little bit different than the last examples. In the last examples, we were given the 2 points here. Find an equation of a line. Bada bing, bada boom. Put a couple steps together. That's perfectly cool. In some of these cases, though, they may be written a bit differently. So let's look at some examples. Sure that it's okay. So let's use this here. Let's go with a line here that give us a line here of 2x minus 3y minus 7 equals 0. So this is the line that we're given. It has to be parallel to this. So parallel to this, and goes through the specific point that goes through a point here of minus 2 comma 2. So thank you for the hydrate. All right. Okay. So we want to be parallel to this line here of 2x minus 3y is minus 7 equals 0 through negative 2 comma 2. Is it supposed to be tricky? No. It just means we just like the thing about being tricky here in these cases is that we just need to make one adjustment here in order to get it to work out firsty. So really that's what the first step here, as you can see, is talking about, is that sometimes lines can be written like this, but it's like, okay, it's just written differently, but now you just need to switch it over to something that you can digest and work with. Like this is a great example of that. So that's why I write step 1 here. It says, if necessary, solve the equation for y. Because if you want to know what is parallel to a line or something like that, you want it in a y equals mx plus b format. That makes most sense to in the context of what you normally work with. It's like it normally works with y equals mx plus b. I know that that's a line or some sort. Okay, well, let's solve for y first instead. All right, and let's just see what we're working with. So that's the kind of mindset that I'm kind of go into in these problems. Like, all right, you know, in my head, I don't know what to do with 2x minus 3y minus 7. But I do know that if I have it y equals mx plus b format, I can do something with that. You know, I can make it easier on myself. So what we need to do is solve for y here. Now to solve for, actually, let's go over this here really quick. How do I solve for y here? What should I do first? What should I do first? How do I solve for y here? What should I do first? I do first minus 2x. Add 7 to both sides. Okay, both. Move them all over. Move them all over. Everything gets moved over. Okay, so I see two. Now if you're saying that move them all over means, say, we subtract by 2x and add 7, both are okay. Both are very valid answers, 100%. We can subtract by 2x on both sides. That's true. We can also add by 7. That part is also true. What they said. There you go. All right, so we're going to have minus 3y here. Now, be very careful about this, okay? Make a note about this here really fast, okay? So on the right side here, we indeed get minus 2x plus 7. That part is easy to see. Be very careful about watching out for that sign. Watch out for signs here. Really important, okay? It's the biggest trip up in this problem here is really at this first step is like, oh, I indeed have minus 3y here. Not just 3y, minus 3y. So again, be careful about signs. You need to be on the lookout for that because signs can easily change in this problem. Divide by -3 would be next. Okay, now here's a question I got for you, Mr. McKeague. That is, divide what by -3? What do I divide by -3? I agree with you, 100%. Just 7? Okay, I agree both sides, but I want it in a slightly different way. Yeah, so let me stop there for just a second, okay? Because the answers here are okay. Like, I agree with the initial assessment here. I said, okay, it is fair to say we divide by -3. I agree with that, okay? Because we want to cancel it out on the left-hand side, no problem. The other part here is we would divide minus 2x plus 7, but the way I want to phrase it here is that what Khadija just said here says, hey, let's divide everything by -3, okay? So when you're kind of doing both sides here, you want to divide everything by -3. So this guy by -3 and this guy by -3 as well. That's what we want here. So it's easy to see if I do minus 2x plus 7 and divide it all over by 3, my minus 3. But in reality, this is what we should be aiming for here, is divide everything by -3. So not just one number, it's all the numbers. Okay. That's another thing I want you to be very aware about here. Again, another piece of warning here, that to divide everything. And I do mean everything. Divide everything. Okay. If this works out for whatever we want to use it for, this is going to be one of those fundamental things for algebra we need to remember. Okay. So again, just covering our bases here, just covering our bases. So you didn't get that right, it doesn't matter. Okay, what this is like one of those fundamental things. Like I want to be sure that everybody understands. Balance. That's correct. It's always balance. 100% correct, Danny. A lot of GGs behind that. 100% correct. That's right. So if we're doing that right, know, wanna get that GG down right there. I'll do the I got an emote for that. I'll do the word EGG. There you go. Okay, so what do we have after we do that? So what we have after that is we have y is equal to, now again, signs can easily change here. So here we have -2 divided by -3. So this is, again, got to be on the lookout for those signs. Instead, we have 2/3 x. We have 7 divided by -3, so that's -7/3. Okay. All right, so this is what we have here after dividing everything by -3 and keeping in track of our sign changes. All right, good stuff. Any questions so far? Any questions? Those basic fundamentals, man. We gotta make sure we clamp those down. We get those going. So I know I take a lot of time on that, but just be sure that we get those down without having to feel super overwhelmed by it. So nip them in the bud. All right. How do I graph fractions? Yeah, graphing fractions is a little bit different. I can show you. I can show you. It's not hard to really graph fractions. You just have to be strategic. So you have to be very strategic about what numbers you choose, Danny. That's how you graph fractions. So it's like if you have, say, you just have to be strategic about what you choose because you want like nice answers at the end of the day to make it easier for you to plot the points. So you can start off with, say, a y, and you can start off with, whatever, a good point, and then go rise over run. In this case here, you would rise by 2, and you go up by 2 and go to the right by 3, and you'd be able to find another point if you wanted to do fractions. Maybe starting from the y-intercept or another point where you get nice numbers. So you just have to be a little bit strategic about that, Danny, if you want to go ahead and graph fractions. Um, you can find you can use your calculator, do it on a little table there. And yeah, with MyMathLab, it can be a bit tricky. So a good suggestion for you is to go ahead and either, look at the table in your calculator there with some nice numbers. Hopefully you get some nice answers back, or write out the XY table like we talked about before. And you should be able to go ahead and do that. Now, in this case here, we may or may not need fractional answers. It just depends. We're not quite there yet at the final stage, but we'll take a look at a graph about that if you want. So that's not a problem. All right, but we do have to move on to this next part here for sure. So let's go ahead and do that here before we get to. All right, so step 2. Step 2 says identify the slope of the line and called it the old slope. Okay, so we have the moldy slope here. All right, so let's talk about that. So what is the slope of this line? Let's identify that. What is the slope of the line that we found here in step 1? Okay, 2/3. Good, good. All right, good. Let me ask a quick question here, really quick question. What if I had this equation? What would be the slope of this line if I had like 5 halves minus 5x? 2/3 is the slope of that line, yes. So I'm just doing a side example here. What's the slope of this line? -5. Okay. Okay, good. Good. So the slope of this line here is -5. The only reason why I ask that is sometimes I get some people saying, well, I see the first number is the slope, which is not true. Okay, 5 halves is not the slope. It's not always the first number. In fact, it's the number next to x. That's how it's going to be. The slope is always the number next to x. All right. That has a thing in there. Okay. I just wanted to do that as a small aside here because that's a common thing. That's why it's better to rewrite it in correct form. Yeah. Um, yeah, you write it in like mx plus b form. Yeah, you can rewrite it like that. But graphing would be up. It'd be left 5 and up 1. Yeah, that's correct. Okay. So we found the old slope here. Now we want to find the new slope. All right, based on the circumstance here. So let's go ahead and do that. Let's find our new slope here. Now, again, as I wrote down here, our new slope is dependent on if it's parallel or if it's perpendicular. Okay. So if it's parallel, then we set the new slope equal to the old slope. If it's perpendicular, we set the new slope equal to -1 over the old slope. So that's why I defined it just like that in the previous couple of questions. So as you can see here, we have the word parallel here in this case. So what would be our new slope here if we have this? What's our new slope here? What's our new slope here if we're trying to find the equation of a line here. So what's our new slope here for step number 3? What do you guys think? We have an old slope here of 2/3. Okay. All right, last slide on it. That is correct. Okay, the answer is also 2/3. Right? The new slope should equal the old slope. Yes, it is parallel. I think that's probably was 3 people off. So yeah, I underlined it up here. We have a parallel case here. Not bad on that. Probably looking for it. Be like, oh, where is it? Yeah, my bad. My bad on that. I'll be like, huh? Why is this taking so long? Oh yeah, well the word is the word. Oh yeah, right. Mm. Inadequacies. Parallel would be 2/3. Perpendicular would be -3/2, not +3/2. -3/2. So as Steven said here, that's correct. Because again, it's the negative reciprocal, the negative flip. Yeah. Nah, it's all good. It's all good, Khadija. It's all good. All good. Not a problem. All right. So 2/3 for a parallel case, and then the perpendicular case, yeah, it would be -3/2. We'll actually do both. Why not? You guys convinced me. Go with that. Oh, I'm being an idiot. All right. All right. There we go. Okay. So let's go ahead and go to step number. Let's go to step 4. Okay. So step 4 says use the slope found in step 3, and at any point given, plug it into the point slope formula and solve for y. So let's solve it for both the parallel and perpendicular case. Again, the point that we're given here specifically, let's write down, we have our two slopes here, the parallel case and the perpendicular case. We were given a point here of -2, 2. So we're going to go ahead and write that down here. So give you a reference. We have a -2, 2 as our point. Okay. We have the parallel slope here to be 2/3, or the perpendicular slope here to be -3/2. So let's take a look at the parallel case here first. All right. So again, what was the really quick here? What was the point slope formula? What's that again? What was the point slope formula? I don't remember. Anybody, give me a refresher. What's the point slope formula here? All right, that's correct. Very good. Yes. Not quite, Khadija. That's the slope between 2 points is what you have there. You have y2 minus y1 over x2 minus x1. That's the that's okay. Look, I think maybe you should switch to Jimmy John's. Maybe that's what's throwing you off today. You know, maybe having the Subway, like it's like a sign. Maybe Jimmy John's is the better submarine place. Or like go to Jason's Deli or something. I'm telling you, you do just do something different and you'll be better off. I don't know. I'm just saying. Lack of sleep, oh, that sucks. It's no fun when you don't get enough rest. All right. I don't know how many of you do that, but I always watch videos until I fall asleep. So maybe that's what's going on there. You know, like I'll watch a video on my phone and I'll eventually fall asleep. That's what I do. I don't know how many of you do that, but I know I do. So I gotta watch like a YouTube video of whatever, and then I'm finally able to just like go to bed. Um, okay. Let's take a look at the parallel case here. So we have y minus y1. Now, if it helps here, get x1 and y1. Same, yeah. Like I'm an old man, man. It's like I need to fall asleep a little bit better, but gotta do it right. I've honestly tried everything. Sleep just doesn't like me. Typically music helps, but my body just refuses. You know, sometimes hey look, to be fair, some nights are gonna be like that. Where you just have too much energy and stuff like that, and you know what? Your body just doesn't want to do it. Listen to ASMR. Listen to ASMR. You'd be like, go in the microphone, right? Be like, oh my goodness, it tastes like victory. You know, stuff like that. Just absolutely outstandingly terrible. Oh man. uh, I just destroyed my mental state. You walked into a math class. What did you expect, Khadija? Your mental state was already going to be destroyed when you signed up for the course. You knew what you were walking into. On top of that, you paid for it too. Welcome to my evil castle. Holy crap. Too good. It's too good. Oh my word. Oh man. I barely would call that ASMR. I barely would call that ASMR. I'm not even trying. There's some things about ASMR that kind of like, there you go. All right. I can't do ASMR either, to be honest. All right. So let's do the parallel case here before everybody goes and revolts against me. I'm mentally hurt. I promise you, there's no more ASMR for the class. All right. I promise you that. Um, All right, so here we got y minus 2 is equal to 2/3, and we have x minus negative 2. So we have x plus 2 here as a result. Again, just cleaning up stuff here, just making sure that we got that all set and ready to go. All right, so here we have y minus 2. We'll distribute the 2/3 here. We get 2/3 x. 2/3 times 2 is going to be plus 4/3. And we'll just go ahead and add 2 to both sides. And what we're going to get here is we're going to get 2/3 x. And then 4/3 plus 2 is going to be, that's going to be 6 over 3. That's going to be 10 over 3. Okay. So here we get our final result for the parallel case anyway. Will be 2/3 x plus 10/3 will be our final answer for the parallel case, just the parallel case. Okay, so we haven't done the perpendicular case yet. Excuse me. All right, so questions about the parallel case there. Thank you for the posture check. Did you? Any questions about the parallel case? We'll go to the perpendicular case there. Questions about that? Okay. All right, so for the perpendicular case, again, we're going to use the same exact point here of x1, y1. Okay, nothing changes in that regard. So we're still going to have y minus 2. Okay, the only thing that changes, though, of course, for the perpendicular case, if we scroll up here for just a moment, is that for the perpendicular case, we have the slope here of -3/2 instead of 2/3. And we still have x minus the -2 here, again, from the point that we're given here. Okay. So again, we'll play a little bit of cleanup. Okay. So here we have -3/2. Again, just change that sign over, x plus 2. So we get y minus 2 here is equal to -3/2 x. And here we have -3/2 times 2 times +2. So that'll be -3 minus 3. And then we'll go ahead and add by 2 to both sides here. We have y is equal to -3/2 x minus 1. And there we go. We got our perpendicular answer here as well. Any questions about that? So that wasn't too bad. Again, doesn't require too much effort. It's just like one little extra thing because of the so basically when you make the adjustment in step number 3, then you don't have to do anything different after that. You're just again plopping in the points there in the point slope formula, still solving for y. So it's a lot more streamlined that way rather than having and making the adjustment in the middle of the process opposed to the end of the process. Yeah. All right. Okay, next, let's look at the next one here. This is the last question for these two sections anyway. Number 8. Number 8 says, how do we find the average rate of change? How do we find the average rate of change? Now, average rate of change is in relation to a function here, but what I do want to actually say here for average rate of change is you can see here if we have an interval a comma b and a function f of x, then the average rate of change is going to be f of b minus f of a over b minus a. Now, albeit this looks really different, in all honesty, this is actually, oh my goodness.
You wrote also twice in your bio.
Oh, did I do that? Thank you, Big Tree. Appreciate the donation of $1. I wrote twice in my bio, did I? Oh, look at that. Well, double the fun? Question mark. Thanks, Big Tree. I'm gonna have to change my bio now. Holy moly. Thank Thank you, Big Tree. That's super generous of you, my man. I don't even deserve it, to be honest. But thank you so much. That's super kind of you. Um, super kind. Hope you're doing well, my friend. Hope you're doing well. Um, uh, okay. The only difference here in this particular case, actually, there is no difference. So there's no difference between number 8 and number 1, which is like finding the slope between 2 points. There's literally no difference here between rise over run, like y2 minus y1 over x2 minus x1, and this equation here for number 8. And that's because, as we've said before, f of x is the same thing as y. All right, we've said that before when we define functions here. So if we look at f of b is just like, okay, well, that's y2. That's the bigger of the two. That's the y2 value here associated with the a would be like x1 and b would be like x2. And so, okay, we get the first y2 here, we get the y1 here, we have x2 minus x1. In our reality, there is no difference between number 8 and number 1. It's just written in function notation, and that's pretty much about it. So if you think of it that way, it's just fancy writing for the same thing for number 1. So essentially, if we look at an example here, all right, look at an example here. Say f of x is x squared minus 4x plus 7. And we look at a particular interval here. Let's look at an interval here between -1 and 3. Okay. Just plop in the numbers here. You could have a and b or whatever. So here we would have f of 3 minus f of -1 over 3 minus -1. Okay. All we need to do is find out what f of 3 and f of -1 is, and then we can go ahead and just substitute those in. Let's do our little side scratch work here, and let's see what we get. Okay. So f of 3 here, pretty simple. Plop in 3, see what we get. So here we get 9 minus 12 plus 7. So is that 16? That's going to be 4. Okay, so we get 4 for the first one here. We'll try f of -1 here. Easy peasy lemon squeezy. And what we're going to get here, we're going to get -1 squared, 20 squared, minus 4 times -1 plus 7. So here we get +1 plus 4 plus 7. So that's going to be 12. Okay. So here we get, in this case, here we get 4 minus 12. 3 minus -1 is also 4. We get -8 divided by 4. So in this case, we get -2. So the rate of change here is the same thing as the slope, and the calculations pretty much bear fruit. It's done the same way, just with function notation. And that's all you got to do for that. So not much going on in all honesty. It's just there. It's just like a retelling. So yeah, pretty much that's it. Okay, any questions about that? No? Okay. Good beans. All right. Check something best. Okay. So -2 is our y then. No, -2 here would be like the slope between like it would be like the slope if you want to kind of call it that there. -2 is the average rate of change. So when you talk about slope for a line there, Jess, you're just basically talking about the average rate of change. They mean they're mean the same exact thing actually. So slope and average rate of change are the same thing, meaning to say in an application, if you increase by 1 unit, then that line would say increase or decrease by the slope, whatever that is. So for a line specifically. So that's what -2 represents. Hope that makes sense there. Question mark. Question mark. Yes. Am I be Yeah, well, that's fine. Okay. I'm fine with that. Okay. Uh are you not sure about that, Jess? Or is that did you have a question about that? Make sense? Okay. Again, if I don't if you want me to clarify it, I'll be more than happy to. So I don't have a problem with that. Okay, now the next one here is gonna take some. It doesn't take a super amount of time, but okay. Let me ask you guys a question. So we could go into the next section here, 2.5, which talks about transformation rules of functions. It's gonna take me a little bit of time here because and we got like 20 minutes left. So I don't know if want me to introduce this section here for the last 20 minutes, or do you want me to hold that off for next week? I'll leave it up to you. I'll leave it to your decision, everyone. Which one do you want me to do? Introduce it now, or just like me to wait until next week and just kind of start on that? Poll time? Okay, let's do poll time. Let's do poll time. All right, you're right. You're right. You're right. We'll put it for 2 minutes, and then I'll have you guys democratically decide. There we go. Got a poll up top there. I'll put it for 2 minutes, so everybody should be able to get it. The democratic process will speak for itself. I'll just follow with whatever. I'll follow it up with whatever. Oh my god. Oh my god. So sick. Why? Call me from. Alright, man. It makes no sense. Alright, we got like a minute left in the poll here. Looks like we have the number. Like we have a few people here. We got well, people who just says wait, wait, wait. You say, hey, you smell. I should have put the third option, hey, you smell. Probably would have been a good third option. That's not the worst option, you know. You could be like, hey, you're dandruff. Like, okay, fair. Try and use that head and shoulder stuff all the time. Good for the hair, but you put too much, then it's like, oh, your hair gets super oily. Thank you for the hydrate there. Thank you. All right, so it says to wait. Okay, so I did the poll here. It says to wait. Okay, so that's what we're gonna do here. It had been decided. All right, so fair decisions here, fair play. So we're gonna wait here to do section 2.5 here for next week. Okay, we're gonna talk about transformations. We're gonna hopefully get through section 2.6 as well. That's on the agenda. Getting through those two sections. We've kind of finished off here a section and a half. So we should be good to go, at least in terms of the pacing. We're on a good pace here. Okay, so just really quick here before we end off here for today. I do want to I do want to just let you know here once again that I will be talking about here the tests next week. Okay, so I'll be talking about the rules here for the test and whatnot. So you're going to certainly find out more details. I just have a lot to do this weekend in order to kind of make those tests up and make sure that the rules are in place, so it's again as fair as possible for everyone here. All right, so that's what I'm going to be talking about here next week, and that way you guys will get the full skinny, all the details there regarding that. All right. So I know a lot of you have questions about that, and it's very valid to say those. I will certainly acknowledge any and all those questions here next week once they are finalized and locked down. I'll give you full transparency about exactly what's going on with that. So that is that. All right, ladies and gentlemen, I want to thank you all very much for coming out here to the stream once again. All of you are absolutely wonderful people. Absolutely wonderful people who are coming out here. We're the very first week of class, if you can believe that. We were just done with 1 week already. But you know, it's been positive vibes here for the first week. Let's keep this train moving. That's for sure. I hope everybody, as always, stay safe, stay healthy, and most importantly, stay sane. Have yourself a great week, everybody. Thank you so much. I love you all. We will see you all next week. Same time, same place, everybody. Take care of yourselves. All right? If you need my help, I'll be on Discord or email me. All right? Have a great weekend, everyone. See you later. All right. Bye!